at some examples of simplifying radical expressions, and if you notice this time, the radical's in the denominator in each one of these, and generally we don't like dealing with that. It's simpler to deal with expressions where the radical's in the numerator. And so I'm going to show you how to get rid of this problem, and the process is called rationalizing the denominator. And the idea of rationalizing the denominator is by multiplying the numerator and the denominator by the same thing, but this thing you multiply in simplifies the denominator. So for example, in part A, I have 1 over square root of A. So here, I'm going to multiply something where I simplify square root of y. Okay, in part B, we have something very similar. I just wanted to show what it looks like with a number and square root of y times square root of y, square root of y. So I have 1 over root 2 if you're going to take trigonometry. And so that's the trick. So my numerator I have 1 times square root of y, and the denominator I have square root of y squared, which is simplified to y, and there it is. It's been rationalized. This is a simpler expression to deal with. So in part B, I have something very similar. I have 1 over root 2, and if you're going to take trigonometry, you're going to see something like this a lot. I just want to show an example that doesn't have a variable, but a real number instead. And the idea is the same though. I'm going to multiply by something that simplifies square root of 2, so how about root 2? So when I multiply in square root of 2 in the numerator, I just have root 2, in the denominator, square root of 2 squared, which simplifies to 2. So there it is, it's rationalized. Now these last three, parts C, D, and E, are a little bit more involved, but the principles still apply. So in C, we might want to simplify it a little bit first in this way. I'm going to write the numerator as the fifth root of negative 4x to the sixth, and the denominator is the fifth root of 8y squared. Now so far nothing simplifies. Okay, but what I'm going to do again is I'm going to multiply the numerator and the denominator by something where the denominator cancels. And so what I recognize over on the side here is that I have the fifth root of 2 cubed y squared. If I could get the exponent in front of the 2 to be a 5 and the exponent from the y to be a 5 as well, this thing would simplify. So that's exactly what I want to do. I'm going to multiply in the fifth root of, let's see, I needed a 2 to the fifth. I have a 2 cubed. So how about I multiply in 2 squared? Because remember, when you multiply, you add the exponents. And I need a y to the fifth. I have y squared. So why don't we multiply by y cubed? And I'll do that in the numerator and in the denominator. Okay, now in the denominator, this works out great. Because notice here, I have the fifth root of 2 to the fifth, y to the fifth. In other words, I have 2y. Okay, now in the numerator, I have the fifth root of negative, let's see, I have 2 squared times 2 squared, so that's 2 to the fourth, x to the sixth, y cubed. Does any of that simplify? Well, actually, yes, because here I have an x to the sixth, which means that it's an x to the fifth times x. So I can, since I have something to the fifth power, I can take that out of the radical. And notice I can also take out the negative, because that's like a negative 1 times this thing. The fifth root of negative 1 is negative 1. Okay, so I have a negative x times the fifth root of what's inside. I have 2 to the fourth, and that is 16, and a y cubed. And the denominator I have a 2y. And there it is. I've rationalized my denominator. Okay, question. Can I cancel out the y here with a y up here in the numerator? The answer is definitely not. Because remember, this is not a y cubed. This is the fifth root of y cubed. So I can't cancel out with y. This time, I don't have just one square root. I have 2 square roots being added together. So there's a trick to this. You need to file this away. If you're going to take calculus, really pay attention here. This technique is called multiplying by the conjugate, and you'll see it again in complex numbers as well. The trick to simplifying this is by multiplying the same thing, except you flip the sign. So the square root of 11 minus the square root of 5 in the numerator and in the denominator. Okay, so let's pay attention to the denominator first, because does this really simplify it? Well, FOIL it out. Okay, so I'm going to do first, that's the square root of 11 times the square root of 11, which is the square root of 11 squared, which is 11. Okay, then the outside, I end up with a negative square root of 11 times 5, which is the square root of 55. That doesn't simplify, but that's okay. Now multiply in the inside, and when I do that, I get a positive square root of 11 times 5. And notice that those two are going to subtract out. And then lastly, when I multiply my last terms, square root of 5 times the negative square root of 5, I end up with a negative square root of 5 squared, which is just 5. So notice all the radicals canceled out. Now in the numerator, there's really not a lot I can do. I'll just say 6 times square root of 11 times the square root of 5 like that. And now I end up with 6 times the square root of 11 minus the square root of 5 over 11 minus 5, which is 6. Oh yeah, and there's one more thing I can do. Since there's a 6 in everything in the numerator and a 6 in everything in the denominator, it can cancel out, and I'm left with root 11 minus root 5. And there, not only have I rationalized the denominator, I didn't even have my denominator as 1. It completely simplified. Alright, let's try the same technique in part E. So this time, I'm going to multiply by the conjugate, which is a 5 minus root x, in the numerator and in the denominator. So let's worry about the denominator first, and I'm not going to do any sort of multiplication in the numerator yet. Okay, and a lot of times it's helpful not to, because you'll see a better picture once the denominator is simplified. Okay, so we're going to do the first terms again. That's 5 times 5 gives me 25. And then when I do the outside terms, I end up with a 5 minus root x. The inside terms, I end up with a 5 times root x. So that looks like this. I end up with a minus 5 root x for the outside and a plus 5 root x for the inside. And if you notice, those are going to subtract out. And then my last terms, I have root x times negative root x. And so that simplifies to negative root x squared, which is just x. So now I end up with, just to clean it up a little bit, I'm going to have 25 minus x, and I should have said 25 minus x up there, not square root of x, times 5 minus square root of x over 25 minus x. And now again, notice everything in the numerator has a 25 minus x in it. Everything in the denominator has a 25 minus x in it. I can factor those out and cancel. So I end up with 5 minus square root of x. And so hopefully you can see that rationalizing the denominator. So hopefully you can see that rationalizing the denominator, even though it can be a little bit troublesome at times, is very helpful, because this simplified these expressions in a big way. Okay, so I hope this makes sense. This is a very, very useful tool to have. If you have any questions, let me know. I'd be glad to help. And thanks for watching.